Okay, it looks like we are live. So welcome back. Today I'm going to be continuing to work on my fourth interpreter. So let's get into it. So we have all the features implemented. So today it's really just about cleaning stuff up, setting up the project structure, like the directories to be a bit better, because we're gonna have the examples in the source folder. It's not exactly ideal. Yeah, some things like that is what I'm going to work on today. First I'm gonna clean up the code and then I'll do the project structure, maybe write a couple examples, and then also write the README. Yeah. So let's see what we can do here. To start, I'm going to move these things into separate functions, or methods rather, up here, just like how we have these as methods, and then see if there's different ways that we can abstract certain things away so that there's not a lot of repetition. But yeah, so this is colon. So this is basically handle a function. Okay, yeah, so we can do that. Let's just make one. Handle word rather. So we need mute self, and I think well, and we need the tokens. Okay, so yeah, the token that we have, well, actually we might not be able to do that. How do we do that with the rest of them? Yeah, it might not work because then there's going to be ownership issues, and we can't just clone it. So I need a different way to do that. Alright, let me think about that. I can do some of the other ones that did not use that. Maybe I can make a print one. Well, let me see. So emit, that prints it as a character. And then we have also print up here. Should I just make a print function, and then you basically, we really already have the print macro, so this prints a new line, that's fine. Okay. Well, this can be simplified a good bit. And an or, these, I think they would work as yet another macro. So let me just yank this right out of here, and then come up to where we actually define the macro, and make another one. So I'm going to paste that in there, and then I will yank this, and there we go. So I will replace the innards of this with this. Actually, yeah, it's almost the same. Could I actually reuse it? Because, that could work. Because for this one, we can do as i32, and I don't think that would break anything. And then we could just reuse this exact same macro. That might be a good idea. Let me try that. Because we are interpreting it as an i32. We don't need to cast it for most of them, but we could. And then I could just use this in here. So this is how we call it. So yeah, for or, let's try that out. Whoops. Alright, yeah, so I can just go ahead and do that. And then get rid of this. And instead of this, I will put or in there. Or, there we go. Yeah, so let me actually make sure it all still runs. I will run, and I'll use test.forward. Okay. Oh yeah, it's checking for keyword input. I forgot that is what I have in the test. So let me get rid of this, because I don't need that. So let's just do, like, 1, 0, or. And print it out. And let's see what it outputs. Prints out 1, so that's correct. And if we do 0, 0, then it should be 0. Okay. That looks good. And then I need to also make sure the plus works. So I just do something like that. Yeah, okay, so it's all still working. So that is a bit better then. Bin expert. Self and this is and. Okay. No, that is for the invert one. I need to modify the and one. My bad. Right here. Yeah, self and. Okay, yeah, I'm very happy with that. And, whoops, actually need a comment. And then for this one, it's a bit different. So invert is, yeah, we can't really use any of those. It's already very, I think we just do, actually though, self.pop, and then it's just one line, right? Right. Alright, maybe you can't do that. Okay. Yeah, so that won't work then. Okay. That's alright. That is alright. Yeah, there we go. Actually, that is what I want. So, yeah, I'm not sure if there's, should I make this more concise in any way? Okay, that's probably, I want it to be on one line though. I kind of want to try to get them all on one line. Like, this can be one line easily. Like that. Because I think that would look nicer. I can just make an invert function then. Sure. Function invert. And that just needs self, so. And then, yeah, we can just yank this right into there. And we should be good to go. There we go. We just need to, yeah, actually I don't think we have to do anything there. So that should just work then. And then we should be able to call invert on invert. Where is invert? Right here. Self.invert. And just pass self. No, we don't need to do that actually. Just need to call it invert. And, alright, it compiles, and let's make sure it works. So if we have 0 and invert, I think it should be -1. -1, okay, and if we have -1, it should become 0. Okay, all good. All good. Okay, this one. Yeah, so this needs tokens again. So I might need to do something with that. Like maybe integrate it into the structure. I can't really do that though. Yeah, I'll need to consider that. Anything that just uses self like this, it's not too difficult. So for this one, that is a bit different. So you have to multiply it by -1. Why do we have to do that again? Less. Oh yeah, because it has to be. So yeah, I can use the macro for most, like it fills out most of it, but then not all of it. So that's a bit of an issue. Yeah. So. Yeah. I think I might have to make a secondary macro for these ones. Even though it is very similar. Or what else could I do? Could I add another thing? I don't really want to add another thing that we pass into it though. Yeah. Because we could add one there, but yeah. Maybe I'll just make another one. That's okay. So this is what is this for? This is less greater. So these are, yeah. It's still really a binary expression, but yeah, this can just be comp expression. Sure. Something like that. And we just need to do times -1. Yeah, and then we still pass in the symbol, so that's all good. So we should be able to use that here now. Times -1. Yeah. So we can just do comp expr. We pass self, and then we also need equal, like that. There we go. And I should be able to get rid of that, and equals should work. 1 equal dot. That should be -1 then. -1, okay, and if they are not equal, then it is 0. Alright, so that's good. So that is working then. It's not quite as I would, it's not ideal, because I would like to just reuse the other one, but it's alright. It is alright. Comp expr self, and this is greater. And then this one is less. Okay. Whoops, I messed that up. I did actually spell it wrong. Expr. There we go. Self and less. Alright. Perfect. Need one of those in there. Okay. So that should be good then. I should probably handle something here. But that is okay. Yeah, so now let's look at this one. So this one, this has the tokens again, so I'll skip over that for now. This one as well. Then it's just empty. Just move on to something like that. Okay. This uses the tokens again. Okay, this one can just be one line as well. It's not need to be separated like that. Okay, begin. Yeah, that uses tokens, so I'll skip over it. Interpret tokens. This one. Yeah, this one could be fine. Yeah, I think that would be okay. I had a thought. I will wait. So this is, can we move it into a function then? A pop, Can this be like that, or will we get issues with that? Okay, it did compile. Then I could do something like this. And then, okay, I think I'm still probably gonna have to use those, but something like that should work, I think. Okay, it still compiles. Yeah. So that is a bit more concise then, so that'll work. And then I think, so we push that. So we need this else in here. I think we can move this to one line. Is that, then do this. Otherwise we want to pay. So I think we can really just do it like this. Might be a more concise way to write it though. Okay. Okay, well, that's fine. Actually, mess something up. So, limiter is not properly closed. Whoops. Okay, well that is obviously not right. I think I need another one of these. There we go. It still doesn't work. So what else is not properly closed? Oh, is this one not? Yes, okay. There we go. And it compiles. Okay, so yeah, this one. I forget what it's called. We have like the that. Do we have that in Rust? Maybe. I don't remember what they're called though, so I can't. I don't know how to look it up. Maybe I can do because that would be a bit cleaner looking. If let that's not what I want. Okay. Else. Yeah, okay. It's fine. It is fine like this. Fine like that. Okay, so this one just uses self, so I probably will. No, it has the tokens though. And we can't pass that because then it changes the ownership. Yeah. So I will skip over this one for now. So we can pop this and then we push that. So. That and then well, so this they are the same. Well, I guess that one's printing, so it's not exactly the same, but yeah, that's fine. I'll leave it like that for now. This one, pop both of them, set it to that. Okay. Allocate. Yeah, so that maybe there's a better way of doing that actually. On a vector. Is there like left vector fill with range? Yeah, let's try that. Or fill. No, that's not really with range, but fill within range. Essentially, is that a thing? Not shuffle. Yeah, let's look at. This isn't the documentation. Okay, well. Alright, let's see. So vector can create a new one. Can do all that. I don't want a new one though. We have just the. Yeah. Can I fill like I want to fill like a element with 0. Maybe I can just look at fill x elements with y. Is that something that I can find? Okay. Range iterator. Yeah. Okay. Could I do that then? Can you reassign it like that? Maybe. Really, we're pushing to the vector. So, let me try. Stack. Equals 0 to a dot collect. Can I do that? I don't think that's gonna work. Did compile though. Well, we can try that. So if we let me see if I can remember how to do this. We need to make a variable. Sure, it doesn't matter what it's called. And then we need to 3 cells alloc. So then that will be allocated there. And then we can just do balance 1 plus, and then I just want to print the value stored at it. So I can do that. It's not 4. And let's see. So we get 1. 1 is still good, so that's not right. Actually, this is filling? Oh yeah, this is not doing what I wanted to do. Yeah, I should have read the title of that. Extend. Let me look at extend. Is that anything? Extend. Extend. Who's extend? Just extend. Okay, extended from slice, no. Where is extend? Alright, let me just, rest vector extend. No, not concatenate. Let me put that back. So, push multiple values. Splice. Alright, maybe I could just concatenate. Concatenate to one, so make a new one. That is filled to a certain point with zeros. Yeah, I could try to do that, because then it could be a one-line thing. So splice. Could I use that then? Could I do self.memory stack dot splice? And what does one do? Maybe that's not what I want. So rest cat vector. Yeah, so then we can concatenate a new vector with it. So you can't just append it like that. Can I do it in here though? Can I do not append? And then back. And I want 0 a times. Okay, let's see. Can I do oh yeah, as usize. Okay, so it did compile and we did get 0, but if we go out of bounds, then we get out of bounds, right? Alright, yeah, so if we go greater than 3, then we are out of bounds. So that is actually what I wanted. So that is good then. Yeah, that is a bit nicer. Okay, so then this one, that one's fine. Yeah, okay. Then we have key. So this just reads from standard in. That's all good. Okay. And then here is where we handle the word. We need to self.word map. Tokens.clone. I think we could move this into a handle word method. Let me try that. So if I just make one up here called handle words, and then paste this into there. That is a bit too indented here. One more. There we go. Yeah. So, and then we need self. Whoops, select. So we need self, and then we also need tokens. What is tokens again? So that's a vec deck. A vec deck of tokens. And we can just pass a clone to this because that would be fine here. Index. Where's index from? Okay, that's from there. So yeah, I think that'll work fine. So if we now call handle words in down here, or handle word, I guess, is what I should rename it to. Handle word. And we need to pass in tokens. Clone. Clone of it is very important. That would be that. Put a semicolon there, and then we need to change it to handle word. Okay, now if I run it, self.handle word. Yes, that is what I need to do. Where is word? Yeah, self.handle word, and let's see. Word is not found in the scope. Oh yeah, so we need see, where is word? Where does that come from? Okay, so we just need to pass the word. Which is it a string? Well, we could probably just pass the reference to it then, and then not add this here. I think something like that. Okay, I think that is what I need to do. So we need to pass the word. But where did the word come from? Oh, it's from in there. Oh yeah, I'm stupid. I'm half stupid. All right, word. No, we need to. Yeah, that was right actually. Okay, and let's see. So, yeah, we need to do that, and it compiles. Tokens. Unused variable. So why do we not use tokens? I thought we did have somewhere where we have token. Yeah, tokens.clone. So we are using it there. Oh, but no, it's defined in there, so we don't need it. Okay, yes, that is perfectly fine. Yeah, because we get it from the hash map, so we do not need it there. Yes, alright, so that's even better now. Okay, and now if I run it, it will all compile, and we are all good. Okay, so... Okay, so let me see what else. I think I'm going to replace some places where I have unpack. It's unwrap actually. That's what I meant. And thing to expect. Because I still want it to just crash. So I'm not gonna like have errors and then return them and stuff like that. I just want it to crash when we encounter one. Because we don't want it to keep going because there's no point in that. So this is failed to read file. So if we pass an incorrect file, then we'll get that. Failed to read file. Yeah. So that is what we want. So we can do that. Where else do we have that? Unwrap. So this is the stack.hop. So dot spec stack underflow. Yeah, okay. So then unwrap as well. Spec, and this is stack underflow as well. Okay. Yeah, I'm not gonna give like precise locations or anything like that. Unwrap. Alright, so that was the only other place. Huh. Let me go to pop as well, the pop function. And do we have... Yeah, so we actually handle it like that. So, that's probably fine then. Okay, so that is a bit better then. Is there anywhere else? Anywhere else? So, panic. What is this? Why are we doing this? We have ASD. What is this? I have no idea what I was thinking here. Word equals some word.toString. Okay. So do we need to panic here then? Unknown word? Huh. Unknown keyword, I guess? I don't know. Not sure what that's about. So what is this? Word is never read. Why is it not read? This word. 81. So why is it not? Because we are using it. Word. Let's see what that says. Okay. Yeah, so we can print it out. That's fine. So, okay, token. Alright. Else links out for... Alright, so that's all good then. I'm also going to change this. So just make, like, in the interpreter, make a new function. So that we can have a new... Like, we had that in... Let's see, what is the... In the... In the Lexer, we had this. So I'm going to do this, but then for the interpreter. So let me copy everything that we need for it. And some stuff we will pass then, and other things we will not. It's not the Lexer. I should probably clean that up as well, move it around. Okay, so here is what we need. Alright, so we need the stack, which is a new vector. Good, if stack as well, and memory stack. That is new, so false, and then this, we're initializing a loop like that. I think that's fine. Alright, yeah, so all of that can just be like that. So this can just be reduced down to equals, let's see, how do you call it again? It is like interpreter, yeah. Interpreter, colon, new. And I think that should still all work then. Yep, alright, so that is much better now, much better. And then we interpret the tokens. This, could we do the data parsing in the actual lexer, like a method? So, like basically generate the, let me try that. So let me just grab this. And so this will be called like lexer dot generate tokens. Or is it like lex data? Something like that. And then I'm not sure what we're going to pass yet, but we can go up to the lexer and add a new method for this. Which is all the way up here. Lex data. And we're going to do this. So then we're going to see what we will need for that. So lexer can instead be self. Because that is what it is. It is itself. Data.clone. Okay, token. Let's get over that word. Alright, it looks like we don't have lexer anywhere else. So we just need the data. Which is, what is the type of data again? Which is a vecdexter. Okay. Data. So if we do data in there, do we need it anywhere else though? I don't think we do. Oops. Let me delete this. Yeah, so it looks like we don't use anywhere else. So we don't need to clone it or anything. So that should be all good then. To just have, we need self. We also need data, which is vecdec of stir. So hopefully that all works then. Okay, and let's see. Move this mute. Alright. Yeah, so you don't need that. But it will be mutable in here. So can I do that? Okay, so it wants me to get rid of that. Alright, sure. And there we go. So that actually looks like it worked then. That was not too difficult. So is there anywhere else we could condense this? This should really be done in the read file. And just return that. Can I do that? Could I just, if I comment this out, instead I would like to do let raw, or let data instead equal lexer.read file args1. So I would like to call that, and it would return a vecdec of slices like that. That is what I would like to do. So that should work. Yeah, so I need to just change this to include this line basically. So yeah, up in the read file, right here. Let's see, so will that work? And then just return data. So that might not work because, yeah, expected vectec find string. Oh yeah, because this needs to be changed then. Okay, yeah. Okay, that's that. Raw, it is now raw data. Whoops, and there we go. Okay, second, yeah, so these are two mutable bars, so that is what I was worried about. So how could I fix that? If I could at all. Yeah. Alright, so can I borrow Lexer? Actually, that is where it is getting upset. So, why does it do that? So Lexer, yeah, so we actually want, wait, where are we doing that? Okay. Lexer.lex data. Huh. Okay, so can't do that. But what if we just handle it all in here? Can I do that? Just have the data be this, and then call the Lex data. So do this, and then instead of returning it, just do self.read file with data. Yes, we don't actually need this because, yeah, that is not something that we need. And then don't return anything here. Yeah, don't return anything. There we go. And let's see. So, dot read file. Oh yeah, so that's down here. We don't need that anymore. Whoops, and we don't need this either. And we don't actually call read file though, so we do need to call that. Do lexer.read file, and maybe I should change the name of this because it's not really just reading the file anymore. But okay. Yeah. Okay. So go back to read a file. Wait. So why is this? Huh. Self.read. Oh yeah. I see. So whoops. Self.read file on data. Yeah, so we don't want to call that. We want to call the Lex data. That is what I meant to do. So redundant semicolon. Okay. Yeah, I can fix that. But also, first of all, I want to change the name. So instead of read file, it can be basically generate tokens. That is what we are doing. So yeah, we can do generate tokens and get rid of the semicolon, and then it should all still work. And all right, there, it looks like it's all working, and that looks much nicer. So we handle the arg stuff there. And maybe I should make separate variables for the name. Yeah, I think I'll do that. So let me do let file program name, how about that, equals args 0, and then in here we can do usage is that, and then file name.port, something like that, and then put program name in there. And then we can let file name equal args1, and then we can just put file name, like so, and then whoops, yeah, that's not how to do that. Okay, I got confused with Go for a second. Alright, yeah, so then it works then, and we have that, and if we don't provide a file, then we get, usage is that. Yeah. So is there a way to panic without this extra stuff? Basically just crash the program. Let's crash program with message. But without panic. Without panic. It's fine. Alright, yeah, so that's pretty good then. So we interpret that. So this, I feel like instead of the token stack, we should just pass the Lexer. Cause it, yeah, I feel like that would be better. No, but that, reason we can't do that is because of the way that we use it. It's not always we're passing a Lexer. Yeah, so we're not gonna do that. Okay. So now. Yeah, I'm going to move this as well into the into here. I'll put it right up here. And we will need self in here. No, it doesn't do anything with itself. Yeah, so it's just self. And then we want to call get token from word. But instead of returning something, we should just be setting, we don't really want to set anything, though. We do want to return it. So maybe that's not great. Where do we call this? So get token from word. Yeah, so let's just do self.getToken. And let's see. So, yeah, we also do that here. Alright, and we need a test.forth. And it does seem to work. Alright, and let me actually do that on the examples slash fizzbuzz. And it looks like it is all working. Okay, so that is good then. So that is a bit better now. Yeah, so now these are next to each other, the implementations. Okay. Okay, yeah. So that is pretty good then, thus far. What else? What else? Edward. Okay, yeah. So 425 lines. Not too bad. Alright, is there something else that I wanted to do? Let's see. So I'm thinking about this. The tokens. What if we have yet another vector, treat it like a stack, and basically, whatever the current tokens are that we are lexing is what we push onto the top of the stack. So whenever we want to get it, I guess then we would pop it off the stack. Yeah, maybe that won't work exactly. I don't know. I think it's fine. Yeah, it's fine. It's fine for now. Yeah, so I'll leave that. So I think now, I'm just going to write a couple of programs and make sure they all work. So let's see, test.forth. This is just, let me just go into here because there's a bunch of test programs in here. Yes, we have like this. Alright, yeah, so something like this. So basically, he sells a lot. Yeah, and then 10 numbers, 0 cells plus there. Alright, yeah, do this, and then you can set stuff. So this is just an example of an array, essentially. Yeah. Okay, so then, yeah, so 4 cell array. So we make it 3 instead. And then we can just do numbers that, and that will print what is there. So let me do hello run test.forth, and numbers is not a thing because it's called balance. Okay, and it does work. So balance, and then we could do 1 plus, and we would get 20. 1 cells plus is the idiomatic way of doing it. Yeah, 2, and then we can make sure it all works by descending. So we'll get it in reverse order. Yeah, and put a new line after each one as well. And there we go. Yeah, so this can just be an array example. So, whatever it is. Move test.forth into examples slash array.forth. Alright, so what else? Examples, hello world.forth. And this can just be hello world. And we'll put a new line. And then, when I do this, hello run. Alright, so that does work. Okay. So yeah, hello world, and then what else do we have in here? We have the fizzbuzz already. And then let's just make a word.forth and make an example thing. So basically, add to top. Basically, so whatever's on the top of the stack will add 2. So just push 2, add, and then yeah, that is what it will return. So add 2 to top, and we'll just put 5 there. We'll print that out. And then cargo run this, and it does work. Let me put a new line as well, and there we go. So that does work, and I can make a couple more like this. So we could have 2 there, we could have 0 as well, and all of those will just be add 2, and there we go. What else do we have that is interesting? We could do well, that's kind of shown in the fizzbuzz though. Yeah, so yeah, and then I also want to write a README, which basically explains everything and how it works, when it pops from the stack, when it just peeks from the stack, things like that. So, yeah. But I do want a couple of examples that would be useful. So I'm just trying to think what else is like interesting to show off. Maybe just bin stack operators dot and then just do some different stuff like that. So we could have 10, 20, swap, and then Oh, could you do that? And then print, and that will print out a thing, and then also drop the next one because we don't want it, so that'll print out 10. We can also do 10 do plus, and print that out, and that would be 20. And then what other ones we have? So we have dupe, drop, yeah, swap. We also need over. So over, yeah, so that 1, 2, 3, over, dot dot dot, and now we'll print them all out, and it shows how they are changed. And then we also have rot. We rot, and we can do the same thing, except I'm not gonna use 1, 2, 3, so I'll use 69, 69, no, can't be the same. So 20, and 2. There we go. Something like that. And then, yeah, so let me try running this now. I'll go run stack hoppers. And, okay, I'm going to need some new lines, because that is confusing. So, CR, I should probably, wonder if there's a thing, print a new line by default. Because there is, yeah. Alright, and then that is a bit more clear. I feel like I should just put a space, though. No, I'm not going to worry about that. So, yeah, just a new line is good. So that kind of shows off how those work. And then, yeah, defining words is all good. Get an error if we use an undefined word. Okay. Yeah, so I think that's pretty good. That is good. So I will move this examples out of here. Basically, just move examples to dot slash. I think I need dash all. No, okay, that's not a thing. We can just move it. Alright, I guess that works. And then we have examples out here, which is a better place for them. Okay. And we also, yeah, we don't have any dependencies. Yeah, this works. Yeah, no dependencies. So that is cool. So let me do cargo build, and let's go into here. So then we have debug, okay. Then we have forwards in here, and yeah, we don't have a file with it. But we can just go slash examples slash fizzbuzz, and then we can use it. So we now have executable. That's not very interesting, but yes, let me do the readme now. So I'm just going to kind of make something for each thing. So let me do quick start. Yeah, so just need to just git clone this, and then you basically just need to cargo build, and then you have yeah, I think that's all you need. There's no dependencies, so you don't have to install anything like that. So Fork is a stack-based programming language. And let me just kind of let me look at that. Procedural, stack-oriented programming language. Okay. I'll just put that. That's probably enough. Fourth interpreter in Rust. Yeah, I think I'll leave that. Okay, and then this will just be, basically, so you have a couple different things. So, first of all, push onto stack. No, push onto stack. Let me actually make this shell, and then this will be fourth. So I think I can do like fourth. Yeah, and then that should make it fourth stuff. So 0, 1, 0, 1. So in the stack, pushes 0, then pushes 1. Okay, put a gap in there, and then let's see what else we have. So operations on stack, fourth again, and then basically 0, 1 plus sums the top 2 elements of the stack. There we go. Yeah. Okay, and then we have yeah, arithmetic. I probably spelled that wrong. Arithmetic. Yeah, this is how you want to spell it. So let me just there we go. Okay. Valid symbols. Plus, minus, multiply, divide, and mod. Yeah, because it doesn't use the I don't want it to be like that. I think it's not that. Come on. So I'll just do like that. Alright, valid symbol. So those are the with calculations. And then stack movement operations. So basically 1 0 dupe. Or hand, just 1 dupe. Dupe duplicates the top of the stack. And then we have 1 2 swap. Swaps the top 2 elements of the stack. 1 2 3. Let's see. So we have over, which let me look at the implementation of over. Alright, so it takes the second element from the top of the stack and duplicates it to the top. Ooh, okay. Yeah, so I didn't even remember that it did that. Okay, so basically, duplicates the second element from the top of the stack. Okay. 1 2 3 over. Yeah, and then over, and then we have rock. So yeah, we can just have 1 2 3 rock. Takes the third element from the top of the stack and moves it to the top. Yeah, so that is how that works. So those are all of those. Oops. Alright, so next up, output. 2 kinds of output in let's see, so numbers and strings. There we go. So basically 1 2 plus dot. Dot takes the top of the stack and outputs it. No new line. Numbers. Wait, hang on. So we have numbers. Strings. Let's see. Characters and new lines. Yeah, that is a bit more valid now. Okay, so we have one. This, which will print out a string. Hello world. Dot. Yeah, will take the will output everything in every character until the closing one. There we go. Yeah, so that is good then. Okay. What else do we have? What else? Output. CR prints a new line. But then we also have emit. So basically, for the emit, will output the ASCII value of top of the stack. Off the top of the stack. There we go. Okay, so that is good then. So that is output. What else do we have? Alright. Comparisons. Right, fourth, so yeah, we have 10, 10 equal, which is -1 if equal, 0 if not equal. Then we also have greater than, which is -1 if greater, 0 if not greater. If not greater. Yep, okay, and then we have this one. Let me make it actually like that and that. There we go. Okay, so I think that's all the comparisons thing. Then we have also and or yes, we have bitwise operations. Bitwise operations. I'm gonna make it capital. Okay. Yeah. So basically, 0 and no, 0 and let's see. So outputs -1 if and I don't really know how to explain it, or 0 if not. Then we have or, and then invert. So invert actually just takes 1. So -1 if no. So this one basically inverts the output, i.e. 0 into -1, -1 into 0, or 5 into -6. So you kind of figure out what it's doing for that. Yeah, so, or, yeah, if or 0 or not. Yeah, alright, so that is fine then. Then we have if conditions. Alright, yeah. We have a fourth up here. Quite important to do that. Fourth, there we go. Yeah, so then we just have conditions, conditions and loops. And loops must be in words. Which I did not actually have words yet. So let me show that. So I think that can just go right here. It'll go after this. Words. Words are like functions in any other way. That's a way to think about it. Alright, forward. Alright, so you can define it here. Name, and then body. So 1, 2, plus. And then that. So then you call name. Call it with its name. Define a function starting at colon until semicolon. Okay. So that's good then. So then we know what words are. Yeah, so then we have this. So we could have is 0. So basically we just push 0 and then we check equal. Equal. Yeah. 0 and then wait, hang on. Equal and then if, then yes, that is 0. Else, that is not 0. Then okay, is 0. So 1, that is not 0. Then 0, and that is 0. Okay. Don't need a space. We do need that space. There we go. Okay. So we have that. If else. Loops. Okay. So there's two different kinds of loops. Let me look. So first we have the do. Do. Which is, yeah, do I. Okay, so. Let's see. So basically, loop 10. And then 10, 0. Do I dot. Yeah, so I'm just copying what this is. Loop 10 times. Outputs 0 to 9. The I is a special keyword which prints the parent iteration of the loop. Okay. Pretty good then. Okay. Yes, then we have loops, and then, so this is 4, like that, and up here as well. So we have loops, and then this is do loop, and then we need a begin until. Yeah, and then I'll put that in here. Completely mess that up. 4. Alright, so let me do begin until. So yeah, so begin until 0. Yeah, okay, and then begin. So begin, and then we'll do everything in here. So we can just push 1 and then sub, and then check, and then push 0 and equal. There we go. Until it is equal to 0. I'm not gonna test it works. I trust that it will. Until 0. So it'll start at like 10 or whatever. Go until of that is 0. There we go. That's good enough then. Okay, so what else do we have after that? Variables, is that what's next then? Yeah, so variables, bars and constants. Okay, so yet again, yeah, so variable, variable called var on the stack, or let's see, called var into memory. Let's see. push the variable location in memory to the stack. And then we can actually modify it. Let's see, 15 var that. Change the value in memory of the variable. There at get the value stored at the memory of variable. Okay, and then we also have there that get the value stored and output it. Okay, so that's pretty good then. And then we have constants, so we're gonna make this variables. Okay, and then we have constants. Yeah, so constants, let me just look here. So yeah, 50 constant, let's see, size. Then in size, it's the value stored at constant size. Let's see, declares a constant with the value at the top of the stack. There we go. So that is what it does. Arrays. Yeah, so so then arrays basically is just allocating memory onto there. Let's see, allocate space on the allocate memory space. Yeah, okay, so you can just do variable space declare variable or start of memory. Then you can just allocate it. So 15 says a lot. Allocate 15 spaces on the to the memory. Memory starting at the most recently declared variable. And then yeah, you can get it, and yeah, so that's pretty easy to do. Yeah, that makes sense then. Okay, and then keyboard input, yeah. I think I'm gonna put that up here because I think it does make sense to go up here. Maybe like after output. Input. Yes, we just have key. Key. So yeah, just key dot. Just key, okay. Reads input from the user and pushes the character, the key code onto the stack. Okay. That is good then. Yeah. Alright, so that is pretty much everything. So I'm happy with that then. So let me see how it actually works. So let me commit all this. Let's see. Clean some things up. And added examples and updated. So let me push that. Okay, and let's see what we've got. Let me also make sure this works. That's not what I want. I want to copy this either. Let's copy it up here. Hit that, and I want to do it into first test. And then first test. Cargo build. There we go, and then should be in the examples. No, in the target, I mean. In the debug. Yeah, maybe I could turn off debug. And it did work, so that is how you do that. I just wanted to make sure. Is it this one? No. Okay. Yeah, I don't know how to do it. It's fine. So let me just remove that. There we go. Yeah. Into here. Okay. So pushes onto the stack, pushes 0, pushes 1. Alright, makes sense. Does that. Okay. Hello there. How are you doing? How are you doing today? Hello there. I'm not sure how to say your name. I'm just gonna say JP. How are you doing as well? Yeah. Okay. So final function. Yeah. No, it's not a function. It's a word. Then. Yeah. So let me make it define a word. I'm gonna see if there's anything else before I commit it. Okay. So yeah, this output stuff. Okay, that looks good. Key. Yes, there's not too much. This is pretty much full documentation on how it all works. So I am happy with that. Okay. Basically fixed typo. Yeah, one insert. Okay. That should be good then. And what else do we have? Alright, this all looks good, I think. Yeah. What are you building an interpreter? It is a fourth interpreter. Yeah, for the fourth programming language. Actually, pretty much done now. With it. I don't think it's fully featured necessarily, but yeah. So fourth. So this is kind of what fourth looks like. Yeah, it's a stack-based programming language, in case you are not aware. Yeah, so it looks like this. So this is defining a word, which is like a function essentially that you can call, which basically does whatever is in here. So it'll push through in a stack, mod the top two elements of the stack, and then yeah, it performs a modulus operation on them, and then it checks if they're equal to 0. Basically it does FizzBuzz. That is how it all works, if that makes any sense. And then we call it here and put in a new line. So I can show it, forward, and it will output this. And I can change it. You can change the number of iterations right here. So I can make it 100, 101 really. And then run it, and there we go. Let me get all 100. Yeah. So that's kind of how it works. And I have more explanation on how it works in the README as well. Yes. Alright, so what else do I have? Okay. That looks good then. That's the only thing that we have in the lesson. Okay. Could this be condensed in any way? No, that's good. Yeah. So what else? Could this be? Okay. Generate tokens, that's all good. Yeah. I'm actually kind of finishing up now because I got everything done that I wanted to get done. Yeah, so I'm just doing a look through, make sure everything looks good. Okay. Collect. Yeah. Okay. Yeah, there's no flags that you can do with it. Is there? Can I look at like with respects? I want to see. I want to see the standards. Is there something in here? Standard, yeah. Okay. I just want to see. See, is there something good? Because what I've been using is this EZ4. It's just an implementation. And I just implemented all the stuff that it has, other than the extra things. Okay, so what is for? No, I want just like a list of everything. Let's see. Let's see. Okay. Dang, there's a lot of stuff here. Do we have? Yeah. They're actual examples. Do swap. Ooh, okay. So I suppose that is the thing then. Let's look on the Gentoo wiki. What does that have? G4. Let's see. Let's look at this. G4. Can I go to the GNU fourth? Okay. Do we have documentation? Oh, and that actually links back to here. I want to see some code of it. Okay. G4 example. Let's see. Alright, yes, this is a little different. Different the way that works. All good. Yeah, so I think I'll just make whatever I did here. I don't know exactly. Yeah, it was one insertion. All right. Yeah, and then I'm pretty much gonna be ending the stream. Because I did get done everything I wanted to do. Yeah. So pretty much done. There might be some bugs that are discovered at some point. And I might fix them. Probably not on stream though. This is probably the last stream for this particular project. Yeah. So next, there's a few things I want to do. The next thing in Rust that I'm gonna do is actually build like an IRC client. And use that for my Twitch bot because I wrote one in Go previously. And now I want to write it again. Pretty much the same thing. It's not fully featured or anything like that, but pretty much write the same thing in Rust. And then use that and see how it compares to Go essentially. That is the plan. Yeah. So I think we're pretty much good. Yeah. So thank you for watching, and I'll see you next time. Goodbye.